Hello, I'm John Melville, and I'm here to talk to you today about our new ethanol sensor. Now, this is a little ethanol gas sensor that basically can be used to measure ethanol gas in a vapor above water. It's not designed to be put into water or any solutions. It's really only designed to be used to measure ethanol vapor or ethanol gas. It has a limited range. It only goes from 0 to 3%. And you actually need to protect the sensor element using a little piece of Teflon tape. And this will just make it last a lot longer so that it won't get wet, since you are going to be putting it above a solution. So just in case it does fall into the solution, you won't destroy the sensor. To apply the Teflon tape, all you need to do is break off a little piece of Teflon tape, and this Teflon tape is supplied with the sensor. You then remove the cap from the sensor, place the Teflon tape over the sensor, and then gently push the cap back onto the sensor. And if you wanted to, you could trim the excess Teflon tape. And now you're ready to go. This sensor itself does take about 5 or 6 minutes to warm up. I've already connected it to my LabQuest, and you can see it's reading about 0.017% ethanol. It will never read absolutely zero. That's because of the type of calibration that's used. We're using a power calibration. You will never see absolutely zero on the ethanol sensor. This sensor is really designed to be used to monitor things like fermentation. That's really what it's best for. And that's actually what I'm going to show you next, is how to use this CO2 sensor and this ethanol sensor to monitor fermentation. Now, you can calibrate the ethanol sensor if you want to, but you shouldn't need to for an experiment like this, fermentation. If you actually wanted to measure the absolute concentration of an ethanol solution, you could, but you would need to do a 2-point calibration. And you would need to make 2 solutions of ethanol, and you would need to actually tell the ethanol sensor this is 1%, or this is 3%, or this is 0.1%, or 1%. All of those instructions on how to calibrate it can be found in the user's manual, or what we call the sensor booklet. But like I said, for most experiments that biology teachers are going to want to do, you don't need to calibrate the device. You just need to plug it into the LabQuest, wait 5 minutes, and then you're ready to go. Now, the sensor itself also comes with what we call a little fermentation chamber, or a little Nalgene bottle. It comes with a lot of Teflon tape so that you can do a lot of experiments. It comes with a spare cap, just in case your students lose the original cap. And it also comes with this really nice little stopper. And the stopper is designed to be put in the top of this chamber, and it's also designed to be put in the grommet that you find in our large biochamber. So you can place that right in there. And then later I can take the ethanol sensor and place it down into the chamber here. So let me just show you how to set up a very simple fermentation experiment. You just need to fill up this large biochamber with amount of water. It needs to be a little bit warm so it comes to the very bottom of this red mark right there. And then all that I'm going to do is I'm going to take the top off. Now, the reason why I have it on a stir station is because that is going to disperse the ethanol that's being produced by the yeast into the air pockets that are there, and it'll respond a lot faster. Everything is going to work for you much faster if you actually use a stir station and a stir bar if you want to look at fermentation rates. So I'm going to supply our yeast with a little bit of sugar. This is just simple table sugar or sucrose. I'll put some in there. Get a little bit more table sugar. I'm just going to dust that off there. I can mix it up a little bit. There we go, that's spinning nicely. Then I'm going to add just a little bit of yeast. And you don't need to add a lot of yeast. You could add a whole packet of yeast if you wanted to, but you really just need to dust the top very lightly. So I'm going to just sprinkle some yeast to cover the top. Let those yeasts get going. Then I'm going to put this top back on. Then I'm going to place the CO2 sensor into the chamber. Now remember, this is a gas sensor. I don't want to get it wet, so I want the top right here not to touch the water, but to be just above it. So I'm going to place it down into here. And that's why if you actually just fill the level of water to this little red line right here, that you see right here, you should be fine. The CO2 sensor can't be dunked into the water if you just fill it to the very bottom of that red mark. Next, I'm going to take the ethanol sensor, and I'm going to take the ethanol sensor and put it inside of this little stopper, like that. And then I'm going to place the stopper into the grommet and twist it so it's tight. And then I'm going to place this close to the water level. And really now, the only thing that I'm going to do is I'm just going to change the units. I like to have the same units for CO2 and ethanol. You don't have to do that on the LabQuest, but I like having them both read in ppm. So I'm just going to tap on the meter where it says ethanol. And I'm going to change my units to ppm. And then if you wanted to, you could begin recording right now. Normally, it would be best to wait just about 2 or 3 minutes. But I have this whole file set up to record for 10 minutes. So why don't I just hit collect now and we'll see what happens over the next 10 minutes. So you can see right now it's been about just over 5 minutes, and we're getting to the maximum amount that the CO2 sensor can take, which at the low setting, which is about 10,000 ppm. So I'm going to stop it. Now if you wanted to, you could always take the CO2 sensor and put it on the high setting, but you get a much cleaner response if it's actually on the low setting for yeast. And really what you're trying to see when you're looking at fermentation is that yeast can take sugars and they turn that into carbon dioxide gas and ethanol. And you can see that right here on this graph that we have a production of ethanol over time and a production of carbon dioxide over time. And if we wanted to, we could look at the rate of ethanol production and CO2 production over time. Now the other thing that I wanted to let you know is that this ethanol sensor can respond to other chemicals besides ethanol. It's also not temperature compensated and it's not pressure compensated. So we really are using this ethanol sensor to just demonstrate that ethanol is produced by yeast during fermentation. So let's just take a quick look and find the rate of production of both of these gases. So if I tap on the graph and drag across, that's a nice little region where we see that it's increasing. I can just tap on Analyze, and I can select Curve Fit, and then I can pick either one that I want. I can pick ethanol, and then I'm going to choose linear. And you can see that the slope there is about 0.67. And then I could do the same thing for the CO2. I just go back to Analyze, Curve Fit, select CO2, pick my fit, which for most things that we do in biology is going to be linear. And you can see the slope's about 22. And that is a very simple demonstration of how you can use our ethanol sensor and our carbon dioxide gas sensor to look at fermentation with yeast. If you have any other questions about cellular respiration or fermentation or CO2 sensors or the ethanol sensor, just go to our website at www.vernier.com.